Welcome back. Next talk, our next speaker has plenty of experience in building monitoring solutions. He started with NetSaint and now he's up to Icinga 2. He's also founder of the company Sol1, and I would like to welcome Dave Kempe, please.
Thanks. Somehow I've got some fans already. So I just wanted to start this whole thing off. This is about monitoring television stations. I run a sort of open source company, and I'll go through all that in a second. But I figured it would be cool if we actually had a kind of video to start things off. So hopefully this works. This is a clip from a TV show that I saw that we've done a little bit of really bad edits on. This is not a professional editing situation. This is done by IT guys, not TV guys, so don't count that against them. But I thought it was
You were trying to protect me. I'm sorry that you had to die alone. Sorry we didn't have more time.
The guy lying on there, we can figure out which product we're talking about there.
I've seen this before. I thought it would look different. Impressive.
Do not be deceived by its simplicity. The sword of
Icinga
is the most powerful weapon ever forged. Yet it is only as strong as the man who wields it. It will show you your truth, but you must be prepared to see it.
Yeah, that wasn't my my editing. That's awesome. So about us, yeah, we're a open source focused services company. I've been running this company for 18 years now. We've got a bunch of customers from small through to large, and been kind of picking and choosing projects that we like to do, and got 15 staff, and we're from Sydney, Australia. Yeah, so, you know, been around for a while. We're also a full-service Icinga partner, which means we're kind of, you know, commercially involved, and we pay a membership fee, and hopefully that goes back into the development of the products. So I think that's worth mentioning. That's kind of cool. So who are we talking about as well from a customer point of view? I've got two customers I want to talk about. One is Fox Sports Australia. Any sports fans here? Yeah, a couple. Australians are mad sports fans. You know, it's kind of like a religion. We sort of, you know, every Saturday they go and worship at the altar of sport. And so this is a pretty important TV station. Got 6 channels, millions of subscribers, lots and lots of archived video. And we kind of only really have one cable provider, and 80% of people that subscribe to that say they subscribe to that provider for the sporting content, not the movies and all that sort of stuff. So it's pretty important. Second customer is Sky Racing. They're a horse racing channel. Horse racing is important. Is that funny? Is it funny that we race dogs? Yeah, that's cool, actually. I never thought about that. But horse racing is kind of weird, right? Like, I'm not a gambling man or anything like that, but horse racing in Australia, at least, is like kind of a big deal. We literally have a public holiday for a horse race where the whole country stops, and hundreds of millions of dollars are bet on this one day. So to give you, you know, and this TV station is continuously recording and broadcasting horse racing. And then the most important thing actually is the wagering data. So on top of the horse race, you've got how much things are worth, and I'll show you a screenshot, and how much you can bet and all that kind of stuff, and that's very important data. So downtime for a TV station like this that has people making betting decisions, is, I think it's $1 million an hour or something like that in terms of lost real revenue. That's not like deferred revenue or opportunity cost or, oh crap, we can fix it later. It's literally money that just disappears because the race is gone. You can't actually bet on it. So what is television about these days? I'm calling it high-tech legacy. What that means is, it's always been sophisticated. Running a TV station's always been a very large technical challenge, but it's all often been done off, very old school sort of technology, from tape through to, video over cable, which is, SDI. We'll get to that in a second. Keeping a TV station online and actually having things working is the most important thing. Very different to many other sort of, a web server or other IT projects or many other products. What happens right now and the picture that's on the screen right now is the most important thing in a television station. So, it doesn't matter that you kind of were black to air 5 seconds ago. If you're good now, you're golden, and if you're good from then on, it's okay. So everything is designed with that in mind. That if there's ever a failure, you'll have these immediate failover situations. Every system throughout a TV station has a sort of A/B partner where the video feed can always remain online. As a result, for a sufficiently sophisticated system, you end up with a very large infrastructure to ultimately output a relatively small signal that then gets retransmitted to lots of people. So this is kind of like heaps and heaps of machines, all generating a tiny sort of relatively small compressed feed that then gets rebroadcast via satellite to lots of people. It's a kind of cool model. How does a TV station work? You've got cameras. This is a super basic diagram. There's actually hundreds and hundreds of machines in all of these things, that records it. So you take from an SDI feed. SDI is standard video. It's just pure video not over IP, just over an actual cable. Converts it to MXF, which is the typical wrapper format like AVI. Then you do some editing, enrich it with the metadata, store it in a media asset management system, store it in some actual storage. You might send it off to the internet, you might transmit it, send it over to satellite subscribers. So, in Fox Sports' case, there's 700 people that manage this process. And in Sky Racing, it's like 300. This storage at Fox Sports is, 30 petabytes worth of HD video. At Sky, it's like 4. And so the idea is that they keep an archive of all their clips, and they can send you different clips from different days, and cut up programs as well as live events. As I said, large storage requirements. What that means is that the video that's recorded has this huge amount of weight. You have TV stations, and I was talking to the gentleman up the back there who works at another television station. It has this huge amount of weight, so you end up recording petabytes of video onto one particular technology medium, and then getting it out of that and back into something else is extremely hard. I'm looking at migration times of years to move data around, and that's even with the fastest things we can find. So it's a very interesting kind of industry from that point of view. And then, as I explained before, SDI HD, there's a whole plethora of proprietary solutions that go into making video work. There's an entire sort of ecosystem of vendors that all have their own little things. And a lot of that technology is moving from not being a computer to being a computer. And when I say not being a computer, I mean, it's a circuit board that knows how to deal with a video input in, and it can, interlace frames with that, or it can route it to other places, but it's not actually an actual computer. It's a circuit board that does just that one thing. And TV stations are made of these sort of things. This is what a monitoring situation looks like in a typical TV station. You have people that work around the clock. They watch all of the inputs and some of the outputs, and then their job is to make sure that things are getting scheduled in the right place and push the right buttons. You push these buttons, the stuff changes on air. So they can do this is like a mixing desk, if anyone's familiar with an AV mixing desk, for a whole TV station. So these guys are running 6 channels, and they're doing things like booking bandwidth and making sure that this guy's in the right place, and they're getting the feed from this studio and all those kind of things. It's a very sort of real-time operation. This is a video router. Some nice cable porn there, if anyone's interested. Not your normal router. These are all video signals, that come from all the various inputs and outputs, and then get rerouted to all the other inputs and outputs. So, yes, it's a pretty complicated mess. And all of these things are running at 3.2 gigabits, roughly, the data feed on these cables. So there's pretty serious equipment that's all very dedicated. If you add up the actual total bandwidth of the backplane in gigabits, that's quite a lot. But it's not a real router, it's a video router. So it's really kind of like a very sophisticated software patch panel for video feeds. Anyone seen one of these before who hasn't worked in TV? It's kind of cool. Great, got some broadcast people. Lots of bandwidth, lots of fiber. We're moving from standard video over SDI coax to fiber, re-encoding the SDI signal into a fiber, moving it over dark fiber or anything like that. IP stuff is all 10 gig, all very sophisticated networking happens. As I said, data versus metadata is an important point. You can see here on this slide, this is 2 rugby league players. That's, again, an Australian sport. Think of them like football players, I suppose. They're kind of important. And we collect all the stats on them, record them, and then specialized equipment merges those statistics back with the actual video feed for broadcast. And that's the same thing that's going on here. This is just a photo I took of the typical screen at Sky Racing. You've got horses, jockeys, or trainers. How well they think they're going to go, how much you can bet on each particular horse, and how much people have bet already. There's $8,800 on this random horse during the middle of the day. And all this data here, the bottom and all of these things, is coming in as feeds, as text files that come out of XML packets that get translated into commands, and then merged in real time with the video stream using a graphics engine. Which is kind of cool, but there's some serious legacy stuff going on there. So television stations are going from digital. So if you look at those, the small output I was talking about before, we're actually into real monitoring now. This here, there's a $200 million organization. You can represent its entire output with these dB values on a piece of fiber, because all of the whole station comes out, and each one of these values is a channel. If that channel drops below a certain threshold, the check goes critical. But if you go black to air, then these values will be bad. They're moving from that sort of arrangement to more kind of Docker containerized microservices model to service their over-the-top offerings. That's internet streaming, all those kind of things. And the monitoring's had to adjust. We've moved from SNMP queries to API calls as on top of that. So as I said, everything has redundancy, A/B failover. Won't go over that too much, but it does play into monitoring a little bit. When your station is designed with failure in mind, and failure is built into the sort of ethos of how broadcast television works, your monitoring system has to adapt to that. You have to be able to say, it's okay that we're on the B1. That can be warning, and you have to think about, whether or not your failures are critical or just things that are kind of normal part of the operation. So we've had to adapt to that as we've gone along. So we implemented Icinga 2 for Sky and Fox a year or so ago. We were still, kind of a little bit young. There was some things that we needed to work on to make it work, distributed monitoring in particular, and we kind of started with a bottom-down config approach that didn't work so well, and we've moved to bottom up. We've moved to top down, but these are the reasons. Everyone's quite familiar with that. The most important one that I'd highlight, though, is that it's distributed and scalable, and that's the one that we've gone with. So I just wanted to show you an architecture diagram of how it works. We've got a master. The master communicates via the API to, through the internal firewall to the broadcast environment, where there's an actual satellite instance, and that instance has its own checks and executes them all independently, communicates back through the API connection to the master. This connection can be initiated in either way, and you just simply specify where you want the endpoint to be to make that connection work in the direction of the firewall, whichever one you're allowed. So in a DMZ, you always want to establish a connection out. In this particular firewall, I think we're allowed in both directions. Not that we need to be, but we are. And they have an external hosting environment where they've got various other stuff. This line here is an example of a check that we send the we execute a check here that sends mail through a mail server sort of back out to the internet and then back again using the mail delivery plugin. So then that lets us figure out if mail's actually working. Although in Sky's case, they moved to some hosted Office 365, but Fox still have a locally hosted mail server, and so they monitor mail flow. They're about to migrate. But that's an important view of how mail works, for them at least, where you're not measuring whether or not you can connect to port 25 or whether or not you can connect to IMAP or ActiveSync. You're actually sending mail out to Gmail, polling Gmail that it arrived, connecting to Gmail, sending mail back out, and making sure that it goes all the way through your infrastructure, through your mail filters, all the way through the mailbox. So you're monitoring the result, not the intended things. We also bolted on a bunch of other things to make this work: Nagvis, Opsgenie, and various plugins, lots and lots of plugins. And I'll go through those as we went. Here's an example of the Nagvis monitoring overview at Fox Sports. This is taken from a couple of days ago, so there's a couple of things wrong here and there. And this is a Nagvis map. We've got any Nagvis users here? Excellent. There were some bugs with this when we first started out. It wouldn't actually display the right color for what we'd set. The map, we needed to patch that, which we did, and I was very impressed. Upstream accepted our patch within like 2 days, so that was really cool. And these are actually Nagvis lines. They're not squares. They're just really fat lines. So it's a little bit of a hack, but it kind of works. In this case, these are services and these are sort of host-related things. So, for example, RAID belongs in here, but the status of a daemon on a piece of software belongs up here. And then each one of these lines represents up to some hundreds of checks, or even in this case, this is thousands of checks, because this and these guys interact with Zabbix. Zabbix does all their network monitoring, and it has thousands of its own checks. So we've really integrated a bunch of different monitoring systems into the one dashboard, so that the users can see, oh, there's a problem with K2. In this case, one of the FTP servers was down for maintenance and someone forgot to schedule downtime. They just turned it off. And the dashboard plays a sound. They've got monitors around the building with this in the department, the IT department, the broadcast engineering department, the master control room, plays a sound, displays a thing, then they know who to escalate the call to. Sky Racing, similar situation, different amount of systems. We monitor a radio station. There's various, again, same sort of idea, works just as well. In this case, Akamai have got some sort of transcoding issue, and it's always in warning, and that's kind of annoying. So here's another map that we did as well in Nagvis. It's pretty cool. It's a photo I took of the robot. Inside this robot is 24 petabytes of tapes. These are plugins that we wrote that query the TSM storage manager directly. They execute TSM commands, wrap them in shell, run them over SSH. Any TSM users here? Excellent. Happy to share my code if you're interested. We make sure that we've got enough A tapes, enough B tapes. We've got a picture of this is a webcam view of the robot. And everyone kind of, they enjoy that, I suppose. It's fun for the users to see the robots actually working for us instead of taking our jobs. So that's cool. This is another interesting thing. Remember how I was talking about data before? We've got odds and dividends and all those kind of things that flow in. This is a Nagvis map of the data flow that gets data onto the screen. These are the feeds. This particular feed had a problem when I took the screenshot. It's more interesting to have a bit of red and a bit of green. But so these are the fixed odds that are coming in, and then there's the actual data of the races are all coming in via here. These are the API endpoints that we can connect to, and then the data actually flows through this cluster of Windows machines. These are MSSQL, and we're actually executing MSSQL queries on this data to make sure the data is okay. So it's worked out quite well, and I'll kind of go through that when I get to the plugins. But just while the diagram's here, the SQL query says, have you received data? And it checks to see that the last 5 rows have enough data in them. And have you received data? And then it compares the data between the 2 SQL servers and says, are the 2 servers, A and B, close enough together in terms of time? Because they're both receiving data from an independent source, and we want to be able to, at any point, deal with failure and switch from the master to the primary, again, to maintain that A-B backup. This is also a cluster of HA proxy boxes, but you want to keep these diagrams as simple as possible. These are all designed to be 10-foot UI, so you can see them from across the room on a HD screen. I've sort of resized it to make it fit here, but it works well. We also use the Maps add-on, and I'll give you a live demo of this in a minute and walk through that. That's a map of all the pubs in Australia because they all have the satellite receivers. So I've got a really cool interactive map to see if the pub's open. And we can zoom around that later and you can check it out. It's pretty cool. So the other thing we did is, you walk into a typical environment and there's a lot of legacy monitoring. There's all sorts of things. Windows 2003 system running Net Central. I don't know if anyone's got that. Pretty terrible product. Does proprietary SNMP monitoring for a bunch of proprietary equipment. We had Zabbix for networking stuff. And then typically you go and purchase a piece of equipment these days, it's got its own monitoring built into it. A cluster will come with a control panel that says what's working, what's not, and all those kind of things. So we've used a mixture of plugins. We've built an API between Zabbix and here. We've used database queries, and we've got web interfaces that we query or SNMP to aggregate all of the actual monitoring and then feed it through the dashboards and notifications. So that's sort of an important point. We've kind of got this sort of meta monitoring. That's very useful, and it's served our customers well. But I would point out one flaw, and the flaw is that often the checks that you make with say for example to a cluster, the check is the cluster okay? Now the cluster is either okay or it's not okay. The problem with that is if the cluster's got two problems with it, then you might acknowledge the critical alert for it not being okay and start to work on it, but not notice that it's got some other different problem. So we've had to work around some of those limitations. For example, with Zabbix, what we've done is the API queries and says, hey, give me all the groups of switches, and they're grouped by, say, floors or roles in the data center. And the API says whether they're okay or not. For some of the more important switches, the very core ones, we've actually bypassed that entire system and we query them directly because the business decided that it was too important to leave up to an API and some other moving parts to figure out what was going on. Whereas for the less core equipment, we were able to kind of just use the API to filter out what was important, what wasn't, what was in downtime, what wasn't. And again, that's the same sort of thing with a aggregated check from a cluster. So some of the plugins that we had to write to make this work, I just want to walk through some of those things. Any Isilon users here? EMC Isilon? Very expensive, petabytes of storage. So Isilon's this pretty cool BSD cluster. They wrote a big file system for it. It's used commonly in media environments because if you need 3 petabytes of storage that can all do 1,200 megabytes a second with lots of 10 gig interfaces. So we wrote a plugin mostly in Bash, SSH, various parsing things. They're appliances, so you can't exactly install things on them, but you can run a command and get data back and then parse that and continue to work through that. Checks the Isilon, check TSM as I said before. We've got a Graphite plugin. I'm not really sure, we don't really use that too much, so I'm not sure why that's there. Email delivery, we had to fork that to make it work a bit better. Artome's a media asset management system. We've had to write our own plugins that monitor that. This is a common asset management system, and along with Viz1, wherever that is. It's again a cluster of 20 or so machines, each of them doing their own thing, and they have daemons that are being monitored. And part of the logic of that is that the cluster itself takes care of where things should be running. It says, oh, there's a failure over here, I'll move this software to this other place. And the plugin has to deal with the fact that it has to enumerate what the services are, figure out it's okay that that service is now on a different host. And that way you're delivering a better signal to noise ratio for the customers. This workstations plugin, I put that in there because I thought it was kind of cool. We had a hot desking situation. I know lots of people have got hot desking situations. So what we did was we embedded NRPE in the image of all the machines that were being hot desked, and they come and go. It was in a newsroom, so different contractors and reporters are always coming and going and starting machines and shutting them down again. But some idiot decided to put only very small hard drives in them, so they kept filling up with hard drive space, getting full because all the hot desking users' profiles would fill the machines up. So we deployed NRPE with a disk check, and we wrote a plugin that used Nmap to scan the whole subnet of these relevant machines, and anything that was online would then get an NRPE check inside the plugin for disk space, and if any of them were, then it returned a list of machines that the admin had to go and fix. So it's kind of like 2 plugins in once, using Nmap and check NRPE, and simple solution, but works quite well, very robust, very happy with that. A couple of other interesting things. Packet Light is another proprietary SNMP. Well, Packet Light is a fiber optic multiplexer, so you can send lots of fibers down the one piece of fiber. Any Packet Light customers here? Interesting tech, lets you have a single piece of dark fiber and do all sorts of other frequencies and things like that, so you can get Ethernet and video feeds and all that sort of stuff. Great example of a broken SNMP MIB. You can't get any information out of it unless you log in as admin. The read-only thing gives you the uptime and the version, and that's it. And then if you log in as admin with the SNMP password community, you get a whole lot of information back, which is in tables, and they're very hard to parse, and they're very dynamic. I don't know if anyone's tried to get SNMP tables working with plugins, but it's a bit of a nightmare. So I ended up giving up on that. Time is money after all. And we just scrape the web page because the HTML is very static. No one ever changes the firmware on these things. We parse the HTML, get back whether or not it's in error state, output the HTML as text in the body of the check, and works brilliantly. Everyone's very happy with it. And this is core equipment. So if this goes down, bad things are happening. This plugin actually does something very similar. Time is very important in video land. Everything has to be in sync, and Ollie over here helped me write a plugin which makes sure the time on a given machine is in sync with the station clock. There's a bunch of different plugins that already did that, but we needed one that was more aggressive and had a bunch of other features. I can't remember exactly why we did that nicely, but we can ask Ollie about that in a minute. These guys are also web scrapers. This one hits the API. This guy checks to see if a mapped network drive contains a directory, because that was the only way to deal with this sort of legacy system with HA proxy failing over between two different things. I know that sounds pretty bad now I say it out loud. Anyway, so various plugins. Happy to cover any of those if anyone wants more detail. So the workflow is we use Opsgenie to deal with notifications. Opsgenie is a cloud-based service where it has a sort of local connector. It was kind of annoying to get Opsgenie to work in detail integrated with the local config. So what we ended up doing was just sending every single event, every single service notification to it, and then letting the Opsgenie page figure it out. Any Opsgenie users here? It's kind of expensive. Yeah, it's costs a bit of money, but they decided to get every user onto it and sign up. You get an app on your phone. It's great. You get notifications. It can call you, SMS you, deal with all those kind of things. So we just send it the fire hose of things that are going wrong, and then we let Opsgenie filter out which one's correct, which one's not, and how that all works. We use Nagvis, as we said before, and then we wrote a special plugin to notify RT, our ticketing system. So part of our arrangement with these customers is that we provide them with SLA service for certain things. That might be 24/7 support to make sure that given certain clusters are behaving correctly. They've got vendor support for others, and they use us for sort of the gap between their vendor support and other things. And I wanted to just cover that off neatly because I think it's useful. And I just realized that someone else is giving me a talk on the same sort of idea later today, which thankfully doesn't cover RT, so it's still useful. So this is a Notify RT notification plugin for Icinga 2 that we've written, and it follows this workflow. The important thing is to not spam your SLA queue with tickets. The idea is that when you notify RT, you get back a ticket number from the API. You comment on the problem with the ticket number automatically. That way, the ticket is created. And we have a second Icinga instance that monitors RT using the Check RT plugin that we wrote. It's super simple. And effectively says, right, this ticket has been sitting in this queue for 20 minutes. We've got a breached SLA. The on-call person gets a notification. So there's a whole kind of service delivery aspect to making sure that this queue has got tickets that are young, and then there's a whole workflow of something goes wrong, we update it with the ticket, we get on acknowledge, the ticket gets commented on, it doesn't get a new ticket. On resolve, the ticket gets opened so that it doesn't breach our SLA because the problem's been resolved itself, but then we can still investigate it. You could also set it to resolve the ticket on OK again if required. Does that make sense to everyone? Everyone interested in that? It's kind of cool way of dealing with not spamming your queues. We monitor a bunch of databases. Databases is obviously very important for your typical large company. Bunch of DB2 stuff. DB2 has got a client that you need to run and then run queries against. It's important to sort of figure out how that all works. It wasn't too hard. For MSSQL monitoring, we use TSQL directly from a monitoring box locally. I found that to be the easiest way to make it work sometimes. The boxes already generally have the ability to be able to be queried over the network for their MSSQL things. Any TSQL users here, it's a bit of a mess, but it lets you query MSSQL from Linux. Pretty cool. You can then write a query, parse it out, get what you need to do. We've got a variety of stored procedures that let us do monitoring versus actual normal selects or anything else. MySQL, effectively the job for all of these has been to query the box using a plugin, parse the output, and then determine state based off that. So how do we get started? When starting out building a monitoring system for something, and you walk into the building, you're faced with 50 years of legacy equipment that has had vendor after vendor after vendor say this is the correct way to do it. You end up with all these silos of various different things. You've got one guy that says here's how we do this, here's how we do storage, here's how we do whatever it might be. So it can be quite overwhelming. So I'd encourage anyone going down this path to pick something that's achievable to monitor and get that part of it right. Try and build wins that are quiet, they have the right signal to noise ratio, that they're easy to implement, that you're not going to require too many change requests. That's always a constant battle. I think the record for change requests was I wanted a firewall rule open to monitor something. It was some 6 months later that we finally got it to work. So you have to consider your sort of corporate environment when you're dealing with these things. Figure out the important pain points. So what that means is, a lot of people don't really care if MySQL is actually got its port open. So setting up a check TCP for port 3306 doesn't really kind of actually help too much. What they really care about is the data that they've produced is where it needs to be. So you're much better off actually running a plugin that does the correct query and gives you back a result and says, right, there's this many tables, or this is the right data that's there, or all that kind of stuff. Because you get the 3306 for free. The check goes unknown if it doesn't work, or you could set it to be critical. And so you need to figure out, based off talking to people and then interacting with the business, what's actually important to them. Once you've built that thing, then you need to actually test it for noise. So what that means is there's always a point where you write a check, write a plugin, write a check command, and all the syntax that goes with it, where you release it and let it run for a while and let it kind of mature and see if it flaps or not, see if it kind of comes good. It's kind of like a cheese, it kind of has to age a little bit before you know for sure whether you got it right. Time is an important factor with all of these things. As an example, like we do proactive monitoring of backups. Backups are kind of annoying to monitor because their state is often not okay. It's often, the fact that a backup hasn't finished yet. They take a long time to finish. So we make sure that the time period for the backups is reduced to, say between 2 and 3 in the afternoon. We want to check the backups. We don't check the backups outside of that. And then we might check them a few times between that time period and don't worry about it for there. So that's because the backup's only ever going to work by that point. Again, release and refine. What I mean by that is, wait a little while until you tell someone about it. I've set up a check for this. Don't tell them straight away. But they're like, well, it's broken. You're like, well, damn. So be gentle on the boasting about what you've got, and then build value. So what that means is, I always go out of my way to make sure that after that check is in place, I go back to the person who wanted that and said, does this make sense for you? Is there anything else about this that we could actually advise? Is there a way we could refine this to make it more helpful? Many people kind of don't really understand what's possible. They don't sort of understand that I can write a script to query anything. Literally anything. Is James in the room? I can write a script that does that. James is here. It's okay. Actually, no, it's critical. All right, so, and again, in deeper on that, who really cares what they care about? It might not be the person you expect. We've got some fun stories about that the boss might walk in and say, hey, I want a check that does this. And we're like, well, okay, that sounds interesting. But then you wander over to the engineer whose job it is to sit in front of that every day, all day. And he's like, well, we don't actually care about that. We really care about this other thing. So sometimes actually talking to the people that are actually going to use the equipment and be on call and actually have to deal with the fires when they're burning is a much better approach. I realize that involves a lot more legwork, but designing something so that I actually have another slide about this, so that the bottom up kind of adoption is important. So what lessons have we learned? Signal versus noise is crucial. There's nothing quite like making a monitoring system live and then having everyone go, why am I getting all these emails? I'm getting spam, this is shit, I'm just going to delete them all. And then, how many times have you found someone who's got all of their alerts just going to trash, So, because, they're just way too noisy. And, we've replaced at both of these environments multiple systems that were doing just that. They'd spent hours and hours, months and months building a system, a different proprietary system that just ended up generating a lot of noise and everyone just ignored it. So it's really important that when you build something, and this comes back to that user engagement, that people are going to care. It's important that you actually define what it is they care about and they're going to listen, because it's just not worth it. If they're not going to listen, don't even check it. If they don't care if it's cold outside, don't write a check for the weather. That's good, as I said. Don't be afraid to write plugins. I think it's one of those things where when you first approach this, you think that, people don't kind of realize that Icinga doesn't really know what it's doing. It's just a checker. It's an engine that runs things, doesn't understand what's actually going on. And so to get the best results out of defining the things that you care about, you need to be able to write a plugin. Writing a plugin is very easy. It's a, exit code and a string. You can write it in any language you want. And I encourage people, and actually part of the training when I sit down with a sysadmin, I say, right, we're going to write a check. Oh, you care about this thing? Well, we're going to write a plugin. And they're like, what? You mean we're going to write some code? I'm like, well, it's not very hard. I've written plugins in Windows batch file. You can do it. Yeah. You just have to do these things, mate. It's the real world I live in, James. I don't know about you, but it's a real bad world out there. Do keep them in revision control if you're going to do that, though. So good coding practice and encouraging that and building a system where the monitoring system comes to encapsulate what it is that the company cares about requires good practices. You treat the software as a development project and encourage people, and sometimes that's not particularly successful, to track their changes and account for their changes and all those kind of things. You'll have a much better investment in your time. You'll get a better result. So as I said before, sometimes a manager wanders in, waves his arms around and says, hey, we want to monitor all this stuff. It's not necessarily the actual thing that's important. Going and finding that person in the factory that needs to know whether this one thing is actually working is a different situation. So I've noticed that many organizations start with bottom up. We have a monitoring system that a guy turns up one day and it's his favorite pet project and he says, well, I don't know what's going on here until I put in some system that checks that. And the story that is the same. The customers that we've got today, many of those adopted the monitoring that we put in because we said, well, we need to define what it is you care about before we can actually sort of get started. Then what happens is it gets good and the boss says, oh, this is actually working really well. Let's do this. And the problem is pivoting from people building systems that define things they care about to an organization deciding what's important and what's not. There's often a disconnect. And working through that and figuring that out is a matter of consulting and understanding people and letting people provide feedback as to whether or not something's working. Establishing the loop between someone that receives the alert and then is able to actually say, that alert was useless, please get rid of it, is extremely important. And it kind of needs to be mapped out right at the start. How do you say that when I was notified for something, it wasn't important? And you have to figure that out right at the start. So, what is the ideal? Everything should be green. Who's got all green all the time? No one. We're realistic about it. That's okay. It has to be good. But, what I mean by this is you want to get to the point where people know that because the system is checking things proactively, and this is why I love active checks versus passive checks, that they can trust it. They can look on the dashboard and go, oh, I can relax now. It's all green. I can go do something else. I don't have to worry about that. That's where you want to get to. You kind of don't want to be a slave to the alerts, slaves to clicking acknowledge and commenting all the time. You want to get to the point where you can define that. So that requires tweaking levels. Making sure that we're not actually flapping too much or that we've got the right thresholds. And in my experience, aggressively removing checks where that no one's going to care about it. We had a dev cluster just yesterday or day before at Fox Sports, a dev Icinga cluster. It's, I don't know, a couple hundred terabytes worth of storage. The guy just rebuilt it all of a sudden. It's a dev one. He's allowed to do that. That's perfectly fine. We were monitoring it because they happened to have a production workflow on it, which they don't have anymore because he just wiped it. So I was like, you know what? I'm just going to delete all the monitoring for that. Just archive it out of the way. It's not going to be a problem. We'll just get back to me when you're ready. That way, we don't have noise cluttering the system. We're kind of free to go, I'm not just going to acknowledge that and have, pink stuff around. It's just going to be gone. Because it's important, to shepherd that. The other point I wanted to make was about monitoring-driven infrastructure. So I kind of associate this like test-driven development. So it's been hard to get project teams, and I think I might be running out of time, I don't know. I'm close to the end. Project teams to when they're defining a project, to actually create the checks that they want for that project right at the start. So, you get in a new vendor, they turn up. Part of the question has to be, when you're building a new project with a new piece of equipment, is how are we going to support this? And that's not just how are we going to support this in an automated way, which means how are we going to monitor it? Because that's what we're trying to do, is automatically support things. So we haven't quite got there, but I'd like to get to the point, and sorry, this is the ideal, where we can define, right, here is the list of all the machines, and here are the checks for those machines that we're going to implement. We can put the checks into the system, and then as you plug them in and turn them on and make them all work the way that we want, everything just comes green. That's how I feel. It's the same way with test-driven development for software. Ideally, it's all okay all the time, and that's what we're talking about with this part. Anyway, thanks for that. And thanks to Fox Sports and Sky Racing for all the investment they've made in me over the time. I wanted to quickly show you a demo of some of the maps that I had, if that's okay. If my internet behaves, it's a bit bad here. So there's a lot of red here. These devices. This is a real time. These are. Real. This is an actual tunnel to Sky Racing in Australia. These devices are satellite decoders. They are their customers' way of consuming satellite internet. They've got decryption cards in them that retrieve it, and you can only connect them over port 80. So we did a couple of interesting things. But the most interesting thing is the map. And what the map is a map of where all the decoders are. I took the street address out of the database, and we wrote a script that automatically queries the database where they keep track of their data for the street address, and then plotted it to a geolocation using the Google Maps API, update a variable in Icinga for the host with geolocation, and you get yourself a map. It's very straightforward. The Maps add-on's awesome. Who wrote the Maps add-on? He's not here today, is he? I'm going to buy him a beer. Or you can have a free Tim Tam. But then you can zoom in on all these things, and you get this really cool, maps effect. And you can browse through the various options. You can see, we've got show on map here, and we can actually I added an action here, which will let you browse to the web interface of the decoder itself, which is pretty cool. Obviously, it doesn't work from this environment. You need to be behind a firewall. Now, one of the things that was useful here was you can't ping these boxes. They don't allow ping. They've got 5,000 venues around the country, and the firmware, is not going to be changed to be allowing ping anytime soon, because that would require people to go on site to some extremely remote places, as you can see. And so we changed the host check definition to be, can we check to connect to port 80, these, and there's a lot of red on here because the aggregate color of the dots is the worst possible state. So you end up with 500 out of 5,000 being down, but that works reasonably well. So that's kind of cool. I'd love to take some questions because I'm much more interested in answering your questions than anything else. I think that was about it for that demo. Yeah, that was cool. And then I've got also the actual live dashboards here. I don't know if this will necessarily work, but you can click on the links here and they drill down to the actual instance and defines the checks. I can log in and fiddle with that in a minute. But that's about it, I think. If anyone has any questions, I'm happy to answer them. Thanks.
All right. Does it work? Yes. Okay. First question.
I have a serious question and a not serious question.
Sure.
Which is plausibly serious. The serious question is, how difficult do you find it to integrate with your EVS or your Everett's or any of those like systems and vendors? Are they hard to? Do they help? Do they provide some checks?
So Evertz was to pick an example, it's like, oh look, they've got SNMP monitoring. Can we get the MIB? No, that's going to cost you $20,000.
Really?
Well, that's kind of crap. We kind of paid for all this equipment and we're like a really big customer, but why can't we get the MIB? And they're like, oh, that's crap. And I'm like, so we escalated that to their global legal team. We had to sign an agreement. Eventually we got the 120K file. That's the MIB file. 6 months later, I think it was. So, I don't know, does that sound difficult?
Yeah. So some are bad.
Yeah, some are bad, some are good. Like the packet light guy was straight away, but it's terrible and he's not going to fix it. Yeah.
And the silly question is, can you expose this so you can know for users which bars are open and maybe what stations are playing? Like, oh, they're watching the duck race.
You can actually, yeah. The satellite decoder has a. The reason we wouldn't want to do that is because the bandwidth is not high enough. This is all running over 4G networks because there's no fixed line services to Horn Island, but. You could actually do that. There's an SNMP interface for it, and I could literally see that, which channel they're receiving and whether it's working or not. It's pretty cool, but they didn't let me do that because it was going to cost too much money. Thank you. Anything else?
Thank you.
Not allowed to.
When company have some live streams, it's important for them to have some alerts in case of if they have some bitrate, video bitrate drops and things like this. It's the fact. But can this tool make some prediction and analyze the press taps before the down, for example, like audio bitrate drop?
We can obviously monitor things that are available. Now, in dealing with a, proprietary, a zoo of proprietary solutions, you're limited to what vendors are going to allow you to deal with. In the case of, for example, Elemental, they're a transcoder. They've been bought by Amazon. They're starting to, everything's now an API. It's a great thing. We've got a plugin that queries whether or not the video bitrate is working properly. But in the case of a, there's a radio station that we query, and some of that equipment is just, they air gap it. You're not allowed to even plug anything into the same LAN because it's all layer 2 audio. So I think I understand your question. Can you figure out whether or not things are going to break, or there's a performance degradation based on that? It's entirely at the hands of which piece of equipment you're dealing with. But the answer is, of course you can. If you can write a script to query it, then go for it. It's a mere bash script away. Or Go, if you want Go. Thank you. Rudy.
You mentioned on how to. You mentioned that it's important to shorten the feedback loop. So as soon as you have feedback,
Yep.
like an alert is flapping too much, or the threshold is not fine, do you allow the users of the interface to change those thresholds, or does it needs to go through some procedure?
Yeah, there's a team of people that can make configuration changes, and so it's important that we try and make that team as big as possible. And they'll have representatives from various other departments. But the actual, the on-call guy may or may not be able to actually do that. Generally not. Sometimes they're the same people, but Yes and no is the answer to that, unfortunately. I mean, it's one of those things where it'd be nice to be able to have people adjust that, but then people will just adjust things and, instead of acknowledging them and actually fixing problems. So you need to actually have some rigor in service delivery.
Yeah, because and to make this change, they need to change configuration files, or they can use the Icinga web interface to override it.
Yeah, at this point, we're using Director for some hosts and for some things, but it's got a little bit to go, and we've got to roll out a bunch of other things to make that work properly. So it's all configuration files, but we do have it so that you can. It's in Git. There's a web interface for that. You could technically edit the file in Git and commit it from there, and it would flow through to the right place. So it's not out of the question, but we're certainly not afraid of the command line, and neither should anyone else be. So, but that's a matter of training. You've got to be realistic about what people can achieve. Question.
Just one question. Are you receiving and analyzing SNMP traps from your SNMP devices as well and integrating them to your monitoring solution?
Not in these two projects. We decided against that as where possible. So, for example, the sensitive video equipment, you can't just pull the crap out of it with SNMP because it will fall over. So we just reduce the check frequency to make that more palatable. And the reason for that is I much prefer to actually have an active check versus a passive check. And the SNMP trap is a passive check, and so you kind of don't know what you don't know. You don't know if the box has just disappeared or hasn't sent the check or those kind of things. So I much prefer an active check personally, and I try and push for that as much as possible. That being said, customers ask about passive checks all the time and SNMP traps, and I have dealt with them in the past, but I really prefer not to actually have to deal with them because you don't know what you don't know. It's a logical problem. Probably depends on the use case as well. I was talking to someone who worked at a stock exchange.
But they could be very meaningful by complementing active checks.
Yes.
For instance, a last signal from a dying device could be an SNMP trap.
That's true. That's true. The last signal could also be a ping or something.
And then maybe if it's down or unreachable. Yeah.
That's true. But I was talking to someone, it depends on your environment as well. So I was talking to one of the guys at the Australian Stock Exchange, and they use passive checks for lots of things. And that's because in their business, making decisions about where the data is up to has to be up to a human. So that meant that they had people sitting in front of the monitoring system watching it at all times. So the time to recover had to be basically augmented by a person. You couldn't automate it particularly well, and in fact it wasn't in the rules that you're allowed to. So passive checks being received from equipment and then having people act on those passive checks and then switching databases over or stopping the market or doing other more important things was part of their workflow. In this case, it's not really part of our workflow. We haven't had to worry about it too much. I have considered it, haven't got it working nicely. No one's really pushed me very hard for it. But I don't disagree with you. It's certainly appropriate for certain environments. Sure. Any other questions? No? We're good? We're good. Thanks very much for your time. I've got some Tim Tams over here.